everyone, I hope you're having a beautiful, wonderful day. This is our first video in our trigonometry section, and today we'll be covering right triangles. First off, what is a right triangle? A right triangle is any triangle with a 90-degree angle, notated by this little square in the corner here. In any right triangle, the sum of the squares of the legs of that triangle is equal to the square of its hypotenuse. The Pythagorean Theorem, a formula credited to Pythagoras, I'm not sure if I'm pronouncing his name correctly. Either way, he was a Greek mathematician. This information developed the understanding that traveling a certain vertical distance combined with a horizontal distance, one would have ultimately traveled an overall distance unique to its horizontal and vertical counterparts. This information sets the basis for all vector math covered in an upcoming chapter. As you can see here, I labeled the sides of the triangle, C being the hypotenuse and A and B being the legs, with lowercase letters, whereas the vertices of the triangle with uppercase letters to differentiate the sides to the angles. I believe in our next video we'll have a different set of problem examples, but here's one that I have popped up. So here we have side A as 7 and side B as 3, and C is x. It's undefined, so we are trying to find the hypotenuse, or the value of x. To solve this problem, first we're going to write the Pythagorean Theorem, a squared plus b squared equals c squared. Alright, so here's my very bad attempt at color coding, but anyway, what we're going to do is we're going to plug in the sides to their corresponding letters. So we have 7 squared plus, 3 squared is equal to x squared. Now we're going to plug in their actual numbers, so 7 squared is 49, 3 squared is 9. Now we're going to add 49 plus 9, and when you add those together in your calculator, I believe they should be 58. We're going to denote this in yellow, so 58 is x squared. To isolate x, you're going to take the square root of each side, so that cancels out the integer, and you're left with x equals the square root of 58. Now, if this doesn't come out as a pretty number, don't worry about it. Keeping the square root is more accurate, but if your teacher wants a whole number, including the decimals, she might ask you for a certain amount of sig figs. So if she asks you for 3 or 4 or 7 sig figs after, just continue adding numbers after the decimal place, if that makes any sense. Alright, so triples like A, B, C, which satisfy this theorem, are known as Pythagorean triples. These are mainly here for memorization, however I did find this triple generator here so you can mathematically solve for them. This is more just a memorization based thing, but once you get it down it makes your work a lot faster. You want to memorize the special right triangle relationships to work with them so you can easily measure the lengths you can't reach without using trig functions, which we'll talk about in a minute. Let's call the horizontal component leg A. If you've already noticed, the 45, 45, 90 right triangle is also an isosceles triangle. Since the two angles are congruent, the two legs are equal in length. However, as you can see, the hypotenuse is longer. To find its length, you have to multiply the value of the horizontal component to the square root of 2. Likewise, if you're given the hypotenuse, you divide by the square root of 2 to find the length of either side. In a 30, 60, 90 triangle, the vertical component is the value of a times the square root of 3. The hypotenuse in a 30, 60, 90 relative to the horizontal component is multiplied by a square root of 2. And for this last section, we're going to cover trigonometric functions where you're going to pledge your allegiance to the almighty SOHCAHTOA. This nifty mnemonic shows that sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent, as shown in this little chart provided here. How do you know which value is adjacent and which is the opposite? A good rule of thumb to follow is that the opposite of any angle is its corresponding letter side, and vice versa. The adjacent of a value is the remainder side that is attached to the angle but isn't the hypotenuse. Okay, so here I would tell you to pause the video and work these problems out on your own, but I'm pretty sure you're not going to do that. So if you have, that's great. Let's review. Angle A is 62, the hypotenuse is 12 units long, and B is unknown. To find what trigonometric function you have to do, you can see that relative to the angle, you have x is adjacent, and the hypotenuse, 12, is already a given. So you know that you're going to use the function of cosine, which is adjacent over hypotenuse, and then you plug everything in. Beautiful. I'm going to change the color here. We are going to multiply 12 to both sides to cancel out the 12, so that isolates x, and here you have x is 12 times that, and plug it into your calculator. Your answer is 8.08, etc. Okay, so now to the next problem. We have 40 is a given angle. Opposite to that, we have 8, and the hypotenuse as x. So you have the angle is opposite in its hypotenuse. What you know is that, well, now you have to use sine. So sine is opposite over hypotenuse. Sine of 40 is 8 over x. So now we have a function rule with x as the denominator. So what you're going to do here is you're going to multiply either side by x to cancel that out. Now I've isolated 8, but now you have to isolate x, so you're going to divide either side by sine of 40. So x equals 8 divided by sine of 40. That means your answer should be approximately 10.74. Thank you for watching. Please give us any feedback in the comment section and in our Google Forms in the description.